3.2, differentiability. Josh's favorite word. So in your notes, you had the different ways that basically there can like fail to be a derivative at a specific point. We can have a corner, we can have a cusp, a vertical tangent, or a discontinuity. We had a few different things for finding like the derivatives, like some different formulas and stuff that we'll use, and we'll talk about on your calculator how you take a derivative and all of those things, specifically at a point. So, problems. You will probably actually need your book open for these just to see it. It's page 114. So with these, we're looking at the graphs that they gave us. It says to compare the right hand and left hand derivatives to show that the function is not differentiable at point P, find all points where f is not differentiable. And so we have this graph, and you'll see that each of those like pieces of the graph, so it looks like one kind of continuous graph, but we have that part of it is y equals 2, and then the other part is y equals 2x. I have not figured out how to like permanently turn that off, and it's driving me insane. I want to like uninstall the update. Like it makes me so mad.
That's annoying. How often do you have to switch it back off? Like just every time you go out your notes thing?
Every time I start a new section, like a new page of notes, I have to do it. And then everybody's like, why is there a box around the equal sign? Why is there a box around the number 2? Why is there a box? I'm like, no!
Can't help it.
Drives me crazy. And you can't turn it off till you've started writing on your screen. So it's even more annoying. Anyways.
Wait, so you could just start writing and then turn it off and then start recording?
Yeah, but I did that in a class earlier, and I like erased all the writing, and then I had to do it again. It like didn't work. Hello.
Can I give this to you?
Sure. Oh, yes.
Is that
Thank
all right?
you. Yeah, absolutely.
Thank you very much.
All right. So the way we need to do this is essentially I need to take the derivative of both of these like equations of lines. What is the derivative of a constant number?
I feel like it's like 0.
Yes, 0. So y prime is 0. Over here, using the shorthand method, remember we take whatever the exponent is on the variable, we multiply it by the number in front, and then we subtract 1 from it. So what would my derivative of 2x be?
1,
I was gonna say 2.
2.
2. It'd be 1 times 2, so 2.
Wait, so what do you subtract the 1 from? When
The
you
exponent.
From the exponent.
Oh, yeah.
So what this tells us is that at the point 1, 2, because that's where those two like lines come together, we are differentiable everywhere except for at x equals 1, because the point's at 1, 2. 4. So we've got a line and a, why am I blanking? 1 over x.
I know 1 over x.
I don't know why I'm blanking on the name of that function at this very moment, but minor details.
Same thing.
So we have y equals x and y equals 1 over x, and I want to take the derivative of both and figure out what's going on. So what's the derivative of the one on the left?
I think it's
1.
yeah, I think it's 1.
So you take the exponent number, move it to the front, multiply it, so that would be 1x to the 1 minus 1. Well, it's just 1. Now, over here, we have an interesting situation because I have a 1 over x like this. Is there a way that you could think that we can rewrite this?
X to the negative.
So y equals x to the negative 1. Then I can use my general derivative situation. So y prime equals, we take the number and the exponent, we put it in front. So negative 1, there was already an imaginary 1 there, so it's obviously just negative 1. Then x to the negative 1 minus 1, which is what? So this is going to end up being y prime is equal to negative 1 over x squared, because x to the negative 2 would be 1 over x squared, but the negative 1, well, the 1 was negative in front, so negative. And if I evaluate it at the point 1, 1, then I would have negative 1 over 1 squared, which would just be negative 1. So this one is also differentiable everywhere. And I typically abbreviate differentiable because I get tired of writing it, except at x equals 1 because the point was at 1, 1, 1. All right, the next couple, you'll still need your book for reference. So number 6, these ones say the graph of a function over a closed interval D is given. At what domain points does the function appear to be A, differentiable, B, continuous, but not differentiable, C, neither continuous nor differentiable? So these ones just pretty much require you to look at the graph. So on that graph, it looks something like this, sort of, kind of. Where is this differentiable? Essentially, are there any of the situations in the 4 pictures at the beginning of your notes that would cause this to not be differentiable? So this is differentiable everywhere. So at all points in -2 to 3, and that's a closed interval. Is there anywhere that it's continuous but not differentiable? So hint here is if A is all points in the domain, B has to be none.
None.
It can only be continuous but not differentiable if the whole thing isn't differentiable. Are there any points that are neither continuous nor differentiable? None. Because this whole thing was differentiable. So it has to be. Now number 8.
This one looks scary.
So this one's a graph that I've got basically. What just happened?
Oh, I missed it. All I see is a little.
Secant.
All I see is a little.
What is happening?
Oh. It's just.
What?
I'm scared I'm going to erase stuff that's important.
I wonder how many views this one's gonna get.
So confused.
What is happening?
Why like oh it's staying kind of. Why is that one area doing nothing? What?
Oh, it's gone.
Why is it just erasing right after?
It's kind of mustard.
What in the world?
Well, at least we have something.
Bro! Oh no.
Uh-oh.
Oh dear. Anyone else as confused as I am?
I'm very confused.
I'm confused but entertained.
Try scribble.
What?
What? Bro. What is happening?
What? I thought it was gonna work right there. I really did.
Okay, we may have to go old-fashioned here if this doesn't start functioning properly.
Back to the olden days.
What is happening?
Were you trying to see if maybe it was angry that it was you didn't let it suggest stuff for you?
Yes, I was.
Oh.
this is